All right, good afternoon, everybody. So we're still talking about strings. So we're in the string notebook. And at the end of the last class, we had just finished talking about how to find a character in a string. So that was with strchr. If you want the last occurrence of the character in the string, it's strrchr. The funny thing about these well, not funny. What you have to remember with these functions are that they return a pointer to the found character, assuming the character exists in the string. Right? And so if you want the index of that thing, you have to do pointer subtraction. And so in this little example program up here, we have a string, str. We search for the first occurrence of the capital C and store that in a pointer first. And then we search for the last occurrence of the character C, and we store that in the pointer last. If you want the index of those values, you have to compute a pointer difference, right? So first minus str gives you the index of the first occurrence of C. Last minus str gives you the index of the last occurrence of the uppercase C. Right. Notice that the type here is this strange looking type, ptr_diff_t. So this is the type that's used to store the difference between two pointers, right? That's why it's called pointer diff_t. On most of your computers, it's probably defined as unsigned long, although it's actual type you don't care. Right? It's an unsigned. Signed long. It's a signed long value because the difference can be negative. Okay, so string works the exact same way, except it lets you search a string for a substring. Right? It's the exact same thing, except now you're searching, instead of a character, you're searching for the string sub. Right? It works exactly the same way. You're going to call the function, passing in the substring that you are searching for, and passing in a pointer to a string that you want to search. Right? And so this little program here takes in 2 arguments from the command line, and then it searches the first argument for the second argument. Okay. So for example, if you want to search the string ABCDEF for the string CD, right, that tells you that the CD starts at index 2 of the string that you're searching for. Right? If you search for something that doesn't exist, so if you search for the Z, this one tells you that it doesn't occur in the string. Now remember, like strchr, it returns a pointer. So if you want to know, if you have to check the returned pointer every time. Right. So after calling str here, right, the very first thing we do, make sure the pointer that's returned is not null. Right. If it is null, then you know that the thing is not in the string. Right. You have to check if it's not null, because if you want to use p after you call the function, right, you have to make sure it's not null. If you try to use it and it is null, bad things happen, right? And so only if the pointer returned is not null do you actually compute the difference here. Otherwise, it's exactly the same as the previous example. It's just using a different function. Okay, so when you're working with strings, because there's not a whole lot of functionality that's provided for strings, any additional functionality that you want to provide, you typically have to move stuff around in the string. So you might need to move a bunch of characters from one part of the string to another part of the string. You might want to copy characters from one string into another string, because there's lots of things you can imagine doing that you want to do with strings, right? If you don't have a standard library function that does this for you, you have to write your own, or you have to write your own code that performs the operation that you're looking for. So the string header file also defines some functions that let you manipulate memory in the fastest way possible on your that's provided by your operating system. Right. So one of those functions is memcopy. Right. So memcpy. So it is the fastest standard library routine for memory to memory copying. Right. So this thing will copy. It just copies memory. So it doesn't care what the type is that's sitting in memory. Whatever bits are there, it just copies them from one place to another. So the way it works is you specify the location in memory from where you would like to start copying from. So that's source. Right. Notice the type on the pointer is void. Right. So this is a void pointer. Remember what that means? It means this could be pointing at anything. Essentially, the function is telling you it doesn't care what it's pointing at, what this thing is pointing at. It just needs a pointer. Right. So wherever you want to start copying memory from, right, that argument is where would you like to start putting the values into? Right. So that's your destination. Count is the number of multiples of car of memory that you would like to copy. Right. So remember, everything in C is measured in terms of multiples of car. Right. So if you'd like to copy 10 cars, you would pass in 10 here. Right. If you'd like to copy 10 ints, you pass in 10 times the size of int. Right. You want to copy 5 doubles, you pass in 5 times the size of double. Right. This thing does return a pointer. It returns a pointer to dest so that you can pass this function, the result, to another function if you would like. Okay, so here we're going to copy. This little example here is going to copy a couple of different things. So we're going to start with an array X, right? It's an array of int. It's got the values 1, 2, 3, and 4 in. Right? I would like to copy those values into a new array Y. So there's my new array Y. Right? Here I want to copy 4 values. So my count is 4. Right? I could write a loop. Right? Write a little loop, runs 4 times. Each time in the loop, assign xi to assign xi to yi. Right? But you could also use memcopy. So for memcopy, right, pass in the source, right? Where would I like to start the copy from? I would like to start copying from the first element of X, right? So you can use X. You can use the address of X0 if you like, right? X is easier. Where would I like to copy into? I want to copy into the start of Y. So you can pass in Y. Or the address of Y0 if you like. How many bytes of memory would I like to copy? Well, I want to copy that many ints. So count times the size of int. Okay. And away you go. So if you print out the destination array, which is Y, to print out Y, I have a function to do that. Right. So that prints an integer array. It's just a loop, right? Prints out the elements of the array. You get 1, 2, 3, 4. Right. So that really doesn't copy the elements of X into Y. Can you do the same thing with an array of double? Sure, you can do the same thing with an array of double. Do you have to copy the entire array? No, you don't have to copy the entire array, right? So here's my array of double. It's got 7 values in it, right? I still want to copy 4 values, right? So my destination array has room for 4 double values, right? Where would I like to start copying from? Right, so I'm going to start copying from the 4th element of double, right? So double plus 3, so that's plus 0, plus 1, plus 2, plus 3. So I want to start copying from there, right? I'd like to copy 4 values, so I want to copy those elements of double into copy or into CPY, right? So there's your destination, right? How many bytes of memory do I want to copy? I want to copy 4 times the size of double bytes of memory. Right? Does it work? Yes, it works. Right? The destination array is 4, 5, 6, and 7. Right? So you don't have to copy everything out of an array. You can pick which elements you want to copy, how many you want to copy. Right? You can even tell it to copy into another array, not necessarily at the start of the other array. So here I've got an array source, right? So I'm going to copy out of this thing here. I have another array dest, and it's got some stuff in it, right? So why, what, when? Right? I would like to copy the that from source over the what in dest, right? So you just need to find a pointer to start copying from, right? So I need a pointer to that t. A pointer to that t is just source plus 0, 1, 2, 3, 4, 5. Right. So there's my, that's where I'm going to start copying from. Right. I'd like to copy over the what. So a pointer to the w is dest plus 0, 1, 2, 3, 4. Right. And so my destination pointer is there. Right. How many elements do I want to copy? I would like to copy count cars. Right. So I can just write count here. I don't have to write count times size of car. Size of car is always 1, right? And when you run that, sorry, I was playing around with this before class, so I have to rerun it. So when you run that, right, you see that in the destination string, the what has been replaced with that, right? So this is a very flexible way of copying some amount of memory into another part of memory. However, you have to be a bit careful with memcopy. So the one restriction on memcopy that programmers run into problems with when they try to use it is that the memory being copied from cannot overlap with the memory being copied into. Right. So in other words, you can copy, if you're copying from the same array into the same array, you have to make sure that the parts of the array that you're copying from into don't overlap. Right. The reason this requirement is here is because if they don't overlap, memcopy can make assumptions about what it's doing, so that it doesn't have to worry about the overlapping memory problem. Right. So that's the one thing you have to remember with memcopy. Right. There's no checking, right? So remember in C, there's never any testing or validating of the input arguments, right? So when you specify the source and the destination locations, right? The runtime is not going to check whether or not these are valid, right? Furthermore, when you specify how much memory you want to copy, right? It has to be the case that wherever you're copying into has enough memory to hold the copy to memory, right? If that array dest isn't big enough to hold count values, you're going to have a problem, right? How are you going to know you have a problem? If you're lucky, your program crashes, right? If you're unlucky, you find out much later on when something strange happens, right? Okay, so that's how you copy memory from one location to another where they don't overlap. If the memory locations overlap, use memmove instead. Right? Memmove is exactly the same as memcopy, except that you can copy into overlapping areas of memory. Right? It's exactly the same. Right? You specify a source pointer, you specify a destination pointer, right? You specify the amount of memory to copy, right? And away you go. Right? Exactly the same as memcopy, except it works if you have overlapping memory. So for example, here I only have one array, X, right? And I'm going to copy from X into X. Sorry, I'm going to move memory from X into X. I don't care if the memory overlaps. Memmove will take care of that. It will take care of that problem for me, right? So I'm going to print out the contents of the array first to show you that X really is 1, 2, 3, 4, 5, 6. Right? And now I'm going to move some elements from X on top of other elements in X. Okay, so starting at index 5, so that's the last element of X, right? That's index 5 of X, right? My destination is going to be 0, 1, 2, yes. My destination is going to be the 6, right? Is that right? 5, 0, 1, 2, 3, 4, 5. That 5 should be a 4 because I'm doing this here. Sorry. I think in the notebooks it is a 4. I was playing around with this before class. Right. So I'm going to copy. Sorry, 0, 1, 2, 3. So here. So the destination is going to be there. I'm going to overwrite the 5. I'm going to overwrite the 5 with everything in the array that comes after the 5. So in other words, I'm going to overwrite it with a 6. Right. So my destination is X plus index. Right. My source is the destination plus 1. Right. The number of elements to copy is just the length of the array minus the index minus 1. So in this case, it's equal to 1. Right. Everything after the 5. Right. And I'm going to move everything after the 5. Right. So that's source, that many elements. Right. And I'm going to move it one position to the left. Right. So this should give you 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 6. Right. The 6 has been copied over that element there. Right. And so you get the 6 here. Right. Notice that it's called memmove, but it doesn't actually move anything. Right. It's actually copying memory. Right. The 6 that was quote unquote moved is still there. Right? So nothing actually, there's no actual moving here, even though it's called memmove. Right? If you change the index to something smaller, so this is 2. So the source is going to be, or the destination will be 0, 1, 2. So we're going to start writing into the array there. And it's going to move the 4 and the 5 and the 6 one position to the left. Run that, and you see that the 4, the 5, and the 6 have indeed shifted over one position to the left. Right? And again, the 6 is still hanging out at the end of the array because memmove doesn't actually move anything. So if you need to copy or move memory from one location to another and the locations happen to overlap, use memmove instead of memcopy. Right, we're going to use this later on when we either implement a string or implement a proper string class. Well, class, something that looks like a proper string class or something that looks like a list in C. Right, so that'll be, I don't know, next lecture or the one after. Okay, printing and scanning strings. So in a different header file, so in standard.io.h, you'll find a bunch of functions that look like printf. So there's a whole bunch of them. Right, so remember printf, this is the way that we've been printing stuff to the terminal. Right. It turns out you don't have to print to the terminal, you can print somewhere else. So you can print to a file, that's fprintf. You can print to a string, so that's sprintf. Right, so instead of printing to the terminal, we're going to print into a string using sprintf. Right, why do you want to do this? Well, it turns out that being able to print into a string is super useful. Right, so for example, when you make a string in Java by adding a bunch of strings together, right, you could reproduce that functionality by using sprintf. Right, instead of concatenating everything together using plus sign, right, print everything into a string that's big enough to hold everything that you want to print, right, or everything that you want to join together. Right, that would be sprintf. So that supports concatenation. Right, it also lets you do things like copy another string. So instead of using string copy, you can use sprintf. Right, print the string you want to copy into the destination string, and away you go. Right. So how does this work? Well, it works exactly the same way as printf. Right, except you now specify where would you like to start printing stuff into. Right, so in other words, what string would you like to print into? Right, that's called our buffer. Okay, so how does this work? Well, it's easiest to look at some examples. Right, so the way this works is you have a string that you want to print into, right? You have a second string that tells sprintf how should it convert the following arguments when it prints into the string, right? And then you've got dot, dot, dot. The dot, dot, dot means you can specify as many additional arguments as you like, right? It will try to process each additional argument according to this formatting string. Right? All right, so how does this work? Here we go. So there is my source string. So I have 0, 1, 2, 3, and 4, right? The length of that string is 5. Right. Okay, I would like to print the source string into a new string. So I'd like to basically copy the string. Right. One way to do it is to use string copy. The other way to do it is to use sprintf. So there's my destination string. Right. How long is the array? It's 5 long plus 1 more, right? 1 for the null terminator. Right. So remember, string length here is 5, right? It doesn't count the null terminator. If I want to copy that string correctly, right, I need to make sure there's 1 extra space for the null terminator. Right, now I can copy the string into destination 1. Right, so how does this work? There's your destination. Right, so I want to print into dest1. Right, what do I want to print into dest1? Well, I would like to print 1 string. Right, so inside double quotes. Right, so this is a string literal %s. Right, 1 argument after the formatting string. Right, so src is the source string. Right, so sprintf says, okay, so I've got 1 thing after the formatting argument. I'm going to interpret that formatting argument as a string, and I'm going to print that into that array right there. Right, so that copies the source string. Right. sprintf returns the number of characters that were written into the destination string. Right. So notice here, I actually have a return value, right? Int n equals the result of sprintf, right? The number of characters written into the string. So if you run that, right, there's your source, right? After calling sprintf, right, your destination string is, well, it looks like it's equal to the source, right? How many characters did it copy or write into the string? Well, it wrote 5 characters into the string. It does not count the null terminator here, right? So sprintf always writes the null terminator into the destination, but it doesn't tell you that it wrote it, right? So this says it copied 5 characters. It really did 6 because there is a null terminator in the destination. Okay. Do you have to copy into the start of a string? The answer is no. You can copy into the middle of a string, right? So here's another string, right? So now this is A, B, C, D, E, right? So it's already the source string. Oh, sorry, it's not. It's A, B, C, D, E, hyphen, 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 right? So I want to copy the 0, 1, 2, 3, 4 over the hyphen, 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 right? How do you do that? Use sprintf, right? So you just changed where the destination is. Right, so the destination is dest3. Right, now I want to start copying into dest3, starting at the first hyphen. Right, so +0, +1, +2, +3, +4, +5. Right, so I'd like to copy into destination 3 +5, which happens to be equal to length here, right? Because length is 5 in this case. Okay, what am I going to copy? Well, I've got one argument after the formatting string, right? So it looks like we're going to copy that argument as a string into this location, right? Again, sprintf returns the number of characters that are written into the destination. So if you go down here and look at what happened, right? There's your destination. There is your final string, right? So it looks like it really did copy the 0, 1, 2, 3, 4. Right? How many characters did it write? It wrote 5 characters into that string. Right? Do you have to copy just the start of a string into another string? The answer is no. You can copy any part of a string into any other part of another string. Right? So here I've got the string CISC220. Right? I want to copy the, what do I want? The 220. So here I want to copy the 220 into the destination. Right? I need 4 characters in the destination because 220 plus the null terminator is 4. Right? Where do I want to start copying from? S, so +0, +1, +2, +3, +4. So now my source string is S +4. It's not just S. I'm going to treat that as a string, copy into the destination array, and away you go, right? So there's your 220. Right? Number of characters written in this case is 3, right? The 2, and the 0. Right? All right, so this formatting string here can be as long as you want, and it can contain whatever you want in it. So it can contain extra characters in the string. Right? So just like printf, right, you can put additional text in this string, and those characters will also be printed into the source, into the destination string. Right? Furthermore, you don't have to print just strings. You can print numbers into strings. You can print doubles into strings. You can print characters into strings. So let's look at some examples of that. So the next example will do exactly that. So the next example, I'm going to use sprintf basically to concatenate a bunch of information into a string. So I want to make a, I want to compute a string that looks like a Queen's course code, right? So like CISC220 section number, right? So CISC220A or something like that, right? So I've got my department stored as a string, right? I've got my course number stored as an unsigned int. Right? I have my section stored as a car, right? They're all different types, right? I would like my course code to be a string, right? So this is a string of length 9, right? So CISC, that's 4, 220, that's another 3, so that's 7. The course code is 8, plus the null terminator is 9. So my destination array is big enough to hold the course code, right? I would like to print the CISC, the 220, and the A into course. Right. So my destination is course. Right. Now I've got three separate sources. Right. So source one is the department. Right. That's a string. Right. Source two is my course number. That's an unsigned int. Right. And source three is my section, which is a car. So in my formatting string, right, I need to tell sprintf how should it treat each one of these values. Right. So %s means treat department as a string. Right. %u means treat num as an unsigned int. Right. And %c means treat section as though it were a car. Right. If these don't match up to the types over here, sprintf will, it doesn't fail, it just doesn't print that stuff into the string. Right. So in other words, if one of these conversions fails, then sprintf stops at the first failure. Right. In this case, it's going to work. But if you have a conversion that doesn't work, sprintf doesn't return an error code. The program doesn't crash. sprintf simply stops printing into the string at the point where it can no longer convert the following arguments correctly. Right. So when you run this program here, right, it does in fact print out CISC220A. Right. Another two examples. Okay, here I want to make the string that looks like a date. Right. So 4, I guess, digits for the year, then a hyphen, 2 digits for the month, then a hyphen, and 2 digits for the day. Right. Okay, so my year, my month, and my day are all stored as unsigned values. They might be stored as signed values, it doesn't matter, right? They're stored somehow. Right. My date, it looks like I need at least 11 characters to hold this date, right? So 4 plus 2 plus 2, that's 8, plus 2 hyphens is 10, plus 1 null terminator is 11. So that looks right. All right, so I want to print into that string, right? What would I like to print? I'd like to print the year, the month, and the day, right? And now we've got a formatting string that looks a little bit different than our previous formatting strings. So here I've got %04u, right? So what the heck does that mean? So the u we know, right? The u means treat this argument as an unsigned value. The 0 means, if necessary, insert a bunch of zeros at the front of the string when you start to print. Right. The 4, oops, sorry. The 4 means when you print the string, use at least 4 characters to print the string or to print the value. Right. So this means here, print the year using at least 4 spaces, right? Treating the year as though it were an unsigned number. If there are fewer than, I guess, 4 digits in the year, you'll get zeros at the front. Right. So I'll edit this code in a second and show you an example of what how that works. Right. Actually, we're going to see it with the day. Right. So %02u means treat the month as an unsigned number or print it as an unsigned number. Right. Use at least 2 spaces to print out the month. Right. If there are fewer than 2 spaces, when you actually print out the month, insert a 0 at the front, right? Or insert enough zeros at the front so at least 2 spaces are occupied, right? And the same thing for the day, right? So notice when this prints out, right? You get 2023, there's four spaces used to print the year, right? At least 2 spaces to print the month, right? At least 2 spaces to print the day, right? Now the day is 3, right? So when it prints the day, it uses 2 spaces and fills in the missing space with a 0, right? So it pads at the front with zeros. If your year was just 23, it's going to print out 0023, right? Again, use at least 4 spaces, right? If when you do the conversion from the year to a string, it uses less than 4, add zeros in the front. right? So there's 24, there's 2 digits in 24. So we pad with 2 extra zeros at the front. Okay. And finally, the one more example here. This one's going to use, what is this using? 0.3. Okay, so here's our postal code. Right, I would like to format this. So I'm going to convert this postal code. I want to insert a space in the middle of this postal code when I copy it over. Right. So the formatted postal code takes up is going to require 8 characters, right? 6 for the postal code, 1 for the space, 1 for the null terminator. Okay, so how are we going to do this? So our postal code is a string, right? Is that point supposed to be there? That point is supposed to be there. Okay. So we're going to start with postal code, right? So we're going to start with the A, right? There's going to be a second argument. So that's postal code plus 3. So 0, 1, 2, 3. So we're going to start, the next argument is going to start at the 2, right? The 0.3s here means, right? Treat the S means print that as a string, right? The 0.3 here means print exactly 3 characters of that string, right? So if you don't specify the number of characters, does the point have to be there? Hang on just a second here. Just looking for it, see if there's an explanation in here, because I forget exactly what each one of these arguments means. All right, we'll try it. Well, I'm going to play around with this in just a second. Okay, so the 3s means when you print the string, use exactly 3 characters, right? If you don't specify the number of characters when you use the S conversion, it gives you all of the characters of the string, right? So it goes until it finds the null terminator. Here it only uses 3, and that's because I want the A, the 1, and the B. Right? And so when you run that, you get A1, B2, C3. I'm just curious as to what happens if I get rid of the decimals, because I don't remember that decimal has to be there or not. Does that work? Yeah, it doesn't work. Okay, so the decimal has to be there. Okay. So for sprintf, you need the decimal there to specify the number of characters to print. It's pretty sure it's different with scanf. All right. And so there's how you can use sprintf to do things like a string concatenation or to compute a string based on a bunch of other stuff that you want to print into the string. Right. Okay, so if you can print into a string, can you read or can you extract information from a string? The answer is yes. Right. So if you want to read information from a string, right, when you're reading the information of the string, converting it into some other type, that's what scanf is for. Right. So here you might have a string that looks like a date, right? And you would like to extract the year, the month, and the day out as numbers, right? As integers of some kind. So you could try to split this thing up and then use A to I or something like that, right? Or you could use scanf. Right? So scanf is the function that scans a string for formatted information, right? The string that it scans is the first argument to the function, right? So it's going to scan, yes, it's going to scan that string, right? The formatting string specifies what information should be extracted from the string, right? And what else, and it also defines what is this string expected to look like. So when we specify the formatting information for this thing here, right, there's going to be some hyphens in it to indicate that we're expecting to see hyphens in the string that we're trying to scan. Now, the ... here is a little bit confusing. So the ... those are what are called your receiving arguments, right? So what scanf is going to do with a date in this case, right? It's going to scan the string. If it finds a 4-digit integer, it wants to store that value into one of the variables that you're going to pass into the function here, right? If that succeeds, it's going to try to scan the month into the next variable that you specify here, right? And if that succeeds, it's going to try to scan the day into the third argument that you specify here, right? Now, it wants to write these values into variables that are owned by the caller, right? Because the caller wants this information back, right? So these arguments here are all going to be pointers. Right? So to use scanf, the caller makes some variables where they want to store the information, right? So in this case, they're going to make a variable for the year. They'll make one for the month. They'll make one for the day, right? Then they will pass pointers to those variables so that scanf can write into those values. Right. All right, so here we go. Let's look at some examples. So here's our string containing a date, right? What am I expecting that date to look like, right? So that's my formatting string, right? So my formatting string looks like that, right? So %u, so unsigned integer, right? Followed by a hyphen, right? Followed by an unsigned integer, followed by a hyphen, followed by an unsigned integer, right? I want to scan the string data for the year, month, and date. So I need to make variables corresponding to the year, month, and date, right? You don't make pointers here, right? You actually need an unsigned value to store the year. You need an unsigned value to store the month. You need an unsigned value to store the day, right? scanf is going to write into these values. The only way that it can write into those values is if you pass pointers to those values, right? So here I'm using address of to get a pointer to each one of those variables, right? Address of year is the address of the year, right? Address of month is the address of the month variable. Address of day is the address of the day variable, right? Call scanf, right? Tell it, what are you scanning? I'm scanning the array data, right? How am I scanning it? Well, that's in format, right? What does scanf return? It returns the number of successful conversions, right? So hopefully in this case, it's 1, 2, and 3, right? So hopefully there's 3 successful conversions, right? The extra stuff like the hyphens don't count as conversions, right? So that hyphen has to be in the string that you're reading, but it doesn't count as a conversion, right? If it's missing in the string that you're converting, scanf stops. It says, hey, there's no hyphen, I'm expecting a hyphen, right? And I was only able to convert the first argument, so it returns 1. Right? Okay, if the number of conversions, question? The address, right? So scanf, right, is a function, right? The function needs to write into variables owned by the caller, right? The function needs to write into year, it needs to write into month, it needs to write into day, right? There's no way for a function to write into those variables unless you pass a pointer to those variables, right? I can't just pass it year because then it gets a copy of year, right? If it needs to write into year, it needs the address of that value, right? Okay. If number of conversions is equal to this value EOF, which on most systems is -1, but that's not guaranteed, right? So you have to use EOF, don't use -1, right? If the number of conversions is equal to that value there, right? Then what that means is that scanf reached the end of that string before it even attempted a single conversion, right? If the number of conversions is 0, it means it wasn't able to successfully convert anything, right? So in other words, it could not successfully convert the first thing that it saw to an unsigned int, right? Otherwise, right, if it's 1, then it was able to successfully convert the year, right? If it's 2, and it was able to do all of this. So it was a successfully convert the year, then read in a hyphen, then convert the month, right? And if it's 3, it was able to successfully parse all of that from the string, right? So if you run that, right, we get year 2023, month is 1, day is 29, right? So let's screw this up a little bit, right? So what happens if I change the 29 to a string? So AC, right? Now we have the year and the month, right? Was not able to successfully convert the day, right? It doesn't have to be, there could be a day there, but there could be a missing hyphen, right? So if there's a missing hyphen, this will be interesting. The month comes as 123 now, right? So in other words, the second conversion converts all of that. That returns the int 123, right? But it wasn't able to successfully convert the day, right? If it's not a hyphen, but it's something else, so suppose it's the plus sign, right? That also causes a failure of the third conversion. So it's not the third conversion fails, right? It's the fact that it's expecting a hyphen, but there's a plus sign here instead, right? So again, only 2 successful conversions. Right? Put that back in. What happens if the second conversion fails? So make it a string. Right? Here the second conversion fails, so scanf stops. It doesn't tell you there's an error, right? You know that the number of conversions though is equal to 1, right? Because that actually printed out. Right. But again, there's no failure here, right? It just stops. It just stops parsing the string. Can you get 0? Sure, you can get 0, right? So remember, our first attempted conversion is an unsigned int. So if I make that not an unsigned int, right, it's going to give you no successful conversions. Now, how do you get EOF? So it gets EOF if you hit the end of the string before attempting any conversions. Right? And so the only way that you can hit the end of the string before an unsuccessful conversion is if there's nothing in the string or if the string is all spaces. Right? So here it reaches the end of the string before attempting a conversion. So the way scanf works is it skips over all white space before attempting a conversion. Right. Which is interesting because if you need to actually parse out the white space, you now have an issue that you have to deal with. Right. So if it's important that you actually read the white space, you have to do some extra work in order to get that, in order to read the white space. Right. Similarly, if you try to parse an empty string, that's also going to tell you that will also cause scanf to return EOF. Right. All right. So if you're having trouble with that example, you can read through the full explanation in the notebook. Right. It goes over this all over again. All right, so most conversion specifiers consume and discard leading white space before attempting to perform the conversion, right? So in other words, if you try to convert that, it will in fact work. I guess we should try that. So a bunch of spaces, 2023, hyphen, more spaces, 0, 1, hyphen, some more spaces, 5, right? So that works just fine. Right? Why does it work? It's because scanf most of the conversions will discard any leading white space. Right? So %u tries to convert the front part of this string as much of this string as it can to an unsigned int. Right? So it reads space, 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 2023. There's a hyphen next, so it doesn't consume the hyphen. Right? And it says, oh, that's just the string 2023. Right? It throws away all of the space at the front. Right? Similarly here, it's going to discard the space at the front. Similarly here, it's going to discard the space at the front. I don't believe it will discard the space in front of the hyphen. It does not, right? So if your formatting string contains a character in it, it's going to try to match that character exactly, unless there's a space in front of the character. If there's a space in front of the character, it will now ignore all of the spaces in front of that character as well. Right, so this now works. Right. Notice this is not the easiest function in the world to use, right? There's a whole bunch of cases that you have to deal with. The documentation for this function is enormous, right? So if you look it up, how to use printf or sprintf or scanf, right, or fscanf, the documentation for it is very long. All right. What other conversions can you do with scanf? Right. So most of the conversions that work with printf are similar for scanf. Right. %d matches any base 10 int value. Right. %u matches any base 10 unsigned int value. Right. %f. Oh, this is one of the exceptions. %f matches a float value for scanf. right? For printf, it matches any floating point value, right? So it also matches doubles. If you want to match a double with scanf, you have to use %lf, right? %s matches any string not containing white space. Right? %c matches a single char value. And furthermore, it's one of the conversions that does not discard white space. So if you need to read white space, it's %c that you're probably using. There's one more that you can use as well, but I guess it's not here. It's not listed in the common conversions. All right, so here's another little example program. I have 2 empty strings, it looks like. Am I scanning into the empty strings? What am I scanning into? Okay, so we're going to try to scan some empty strings, it looks like. I've got an unsigned int x1, I've got an int y1, I've got a double z1, and I've got a char c1. Right. Following program doesn't need to do this. Oh, there's 2 programs here. They're out of order. Okay, that's what's going on. This is the one. Oh, wait, what happened here? Oh, I see what's going on. Sorry, there's been a cut and paste error. Hang on. I don't know how this happened. This is not in the regular notebook, I'm pretty sure. So I have to delete this cell. Insert? No. How do I edit? Delete cell. Yeah. Get rid of this line here, and I have to copy all of this up into the other cell. Is that right? Are we happy with that? Let me try running it and see what happens. I'm not sure I just did that right. Did that work? Okay, that worked. Oh yeah, I had that before. That's weird. All right. Okay, so step 1, we're going to try to scan. We're going to try to scan the empty string. Right. We're going to try to scan the empty string for a string, and we're going to store whatever we get into the string str1. Right. It turns out you cannot scan the empty string. It's not going to work. So when you scroll down to the bottom here, right, you get n equals -1. So n is the number of conversions that is attempted, that were successfully attempted. Yeah. If you get back -1, that means it hit the end of the string before it managed to do any conversions. Right. So if you try to scan the empty string, that doesn't work. It's going to reach the end of the string before anything can be converted. Right. So that one doesn't work. Scanning a blank string. So this does have stuff in it. Right. But if you use %s, %s is one of the conversions that gets rid of blank spaces before it attempts the conversion. So here, it gets rid of all of this stuff, hits the end of the string, and says there was nothing for me to convert. Right. So again, you get back -1. All right. Here we've got the string ABC. That's the one we're scanning. Right. I'm telling scanf to look for an integer of some kind. Right. If it finds an integer, it's going to store it in y1. Right. So obviously, it's not going to find an integer here. So in this case, you get back 0 for the number of successful conversions. Right? Nothing is written into y1. Okay, so here's a non-blank string ABC. I'm telling scanf scan this string, look for a string. Right? If you find one, store it in str1. Right? Okay, so this works, right? We found one string, right? And the string that we found was the string ABC. So that's good, that works. Okay, there's a string there, right? ABC space XYZ, right? Scan that string or a string, right? If you find one, put it in str1, right? So here it does find a string, right? But it doesn't find the string ABC space XYZ, right? scanf uses the space to indicate the that there's a different string that starts, right? So here, ABC space XYZ gets read as the string ABC, right? Second one here, right? So it performed one successful conversion. The conversion that worked was ABC, right? You don't get the space XYZ, right? If you want the XYZ, if you want the XYZ, oh, not yet. If you wanted the XYZ, you would have to insert in another %s here, right? So you'd have to do %s, and you'd have to store the second string in another variable. Oh, we're out of time. Okay. And then I'm going to have to print out the other variable here as well. str2 equals. Okay. Right, so now we get two successful conversions, right? We were able to successfully convert both strings, right? But because of the space between in the string, there's no way to read that out as a single. Well, that's not exactly true. Using %s, you cannot get that out as a single string, right? %s uses space to indicate that a new string has started. All right, I guess we got to stop there. We'll finish off the rest of that example in the next class.